In this video, we will be analyzing the graph of a function to sketch the curve. If you've not already done so, press pause to copy down these guidelines. When you're ready to continue, press play. And the function that we'll be working with is f of x equals 3x squared minus 3x minus 6 divided by x squared plus 8x plus 16. Our first step is to find the x-intercepts by letting y equal 0. So if we let y equal 0 and multiply both sides by this denominator, I'll have 0 is equal to 3x squared minus 3x minus 6. I'm going to factor a 3 out and look at what's left. So we have x squared minus x minus 2. This trinomial factors. So I have x minus 2 times x plus 1. So our x-intercepts are positive 2 and negative 1. Go ahead and graph that. Our next step is to find the y-intercept by letting x equal 0. So we have 0 for this term, 0 for this term, negative 6 divided by 0 for this term, 0 for this term, 16. So our y-intercept is a negative 3/8. Negative 3/8 is not quite a negative 1/2. So I have a y-intercept right about here. Our next step is to find the vertical asymptotes by letting the denominator equal 0. So x squared plus 8x plus 16 equals 0. This factors x plus 4 times x plus 4. So I have vertical asymptotes at x equal negative 4. Our next step is to find the horizontal asymptote or oblique asymptote or the end behavior at positive and negative infinity. Since we have a rational function and the degree of the numerator is equal to the degree of the denominator, I have a horizontal asymptote and the equation is y equals the ratio of the lead coefficients, which would be 3/1. So my horizontal asymptote is going to be y equals 3. Alright, my next step is to determine if my graph will cross this horizontal asymptote by setting f of x equal to the equation of the asymptote. So f of x is 3x squared minus 3x minus 6 over x squared plus 8x plus 16. And that needs to be equal to 3. So multiply both sides by this denominator, and I have 3x squared minus 3x minus 6 equals 3 times x squared plus 8x plus 16. I didn't multiply that through because I can divide both sides by 3 to simplify some. This simplifies to x squared minus x minus 2 equals x squared plus 8x plus 16. The x squareds cancel, and let's add x to both sides and subtract 16 from both sides. So I have 9x on the right and negative 18 on the left. Divide both sides by 9. So x equals negative 2. So that means our graph is going to cross this horizontal asymptote at x equal negative 2. So I'm going to go ahead and show that. When x is negative 2, I cross the horizontal asymptote. So that's actually a point on the graph. Let me make that red, since I know that. Okay. And it won't cross anywhere else. So my next step is to check for symmetry. Looks like we don't have any symmetry, so I'll make a note. My next step is find my extrema concavity points of inflection by checking my first derivative and my second derivative. Do first derivative. We have the denominator times the derivative of the numerator subtract the numerator times the derivative of the denominator x over the square of the denominator. Now this denominator was x plus 4 times x plus 4. I calculated that right here. So this is actually x plus 4 quantity squared. So in the denominator of my derivative, I'll have x plus 4 to the 4th power. This is also x plus 4. I'm looking now to see if I can do any simplifying. This factor is 2 times x plus 4. So it looks like I have an x plus 4 factor in each of my two terms in the numerator that I can cancel with one of these x plus 4 factors. So I'll take one of those. 6x squared minus 3x and plus 24x and minus 12. And then I'll distribute 2 and the negative through this trinomial. So I have a negative 6x squared plus 6x plus 12 over x plus 4 cubed. These cancel. I have a negative 12 and a positive 12. Those are going to cancel. So it looks like 24 and 6 is 30 minus 3. Looks like I have 27x over x plus 4 cubed. That's my first derivative. Now if I set that equal to 0, I'll have critical numbers. At x equals 0, and x equal negative 4 is my asymptote that I found over here. Let's use negative 5 for my test value, and negative 1 and positive 1. If I have a negative 5 up here, this numerator is negative, and if I have a negative 5 down in here, denominator, this is also negative, so this will be positive first derivative. If I put a negative 1 here, my numerator is negative, and my 1 plus 4, that's 3, so the denominator is positive, so my derivative is negative in this interval, and if I put a positive 1 in these two spots, I'll have a positive first derivative. So this is asymptote, so it won't, even though it does change from a positive first derivative to a negative, it's my asymptote, so that won't be a relative min. But this one, there is a change. I'm going from a negative to a positive, so this is going to be a relative min at 0, and we calculated that when x is 0, we got a negative 6 over 16, which is a negative 3/8. So negative 3/8. So we can show that on our graph. We have it graphed, but we would indicate a relative min at 0, negative 3/8. Alright, now we can check our second derivative. This is our first derivative. So our second, let me copy that. First derivative was 27x over x plus 4 to the third power. So our second derivative going to be x plus 4 quantity cubed times the derivative of the numerator, which is 27, subtract 27x times the derivative of the denominator, so 3 times x plus 4 to the second power times the derivative of what's inside, which is just 1. And that's going to be over the square of the denominator, so x plus 4 to the 6th power. Alright, it looks like I have two factors of x plus 4 that I can take out of this term and take 2 out of here. So I'll reduce this. I'll take 2 factors out, and that'll leave me 1 there. And I'll take both of those out, and that leaves me with 4 here. So my second derivative now is x plus 4 times 27 minus 81x, and then x plus 4 to the 4th power. So we have 27x plus 108 minus 81x over plus 4 to the 4th. So this gives me a negative, and when I set this equal to 0, it'll just be the numerator equal to 0. So I have a negative 54x, and that'll be a negative 108. Divide both sides by negative 54, and x is equal to 2. So if I check 2, I can see that test value of 0 here in my derivative, that would be positive, and I can use 3 here. That'll be a negative. So we have concave up and concave down. So I have a point of inflection at 2. Well, that would ended up being my X-intercept, so it's going to be 2, 0. So I have a point of inflection there at 2, 0. So let's see if we can't get our curve drawn. This is our minimum. I'm going to come up here, and we have concave up, and then we have concave down. So our curve looks something like that. And then I have to cross my horizontal asymptote here. Go up my vertical asymptote. And then I also know that on the other side of my vertical asymptote, I'm concave up, which means that at some point over here, I'm going to do a curve like this. Now we could get better estimate of where that's located by plotting points, but for right now, just sketching the curve and knowing that it's going to be concave up is enough.